rhythm, or whatever about the noise, whatever it is that you use physics for. That's what I would like to know, yeah? Also, I would like you to round your student number to 7 significant figures. It seems that not everybody is able to do that. I hope that you can do that. I mean, all of you can do that, okay? And then we go back to mechanics about the rocket, how a rocket flies due to the third law of Newton. Action is equal to reaction or conservation of momentum. Yeah, so I would like you to be able to explain how rockets fly. What is the physics behind rockets flying? Yeah. Okay. I would like us to continue with projectile, correct minimum initial velocity, and also all the angle of release to hit the point with the velocity v. Yeah. So we calculate both angles of release. And also we need to shoot over the obstacle sometimes. So this question shooting from point 0, 0 to point xy through point AB. So you write two equations, one for xy like this one, and the other one will be for AB. So should I do it for AB? Maybe I can try for AB, yeah? So for AB means that y is B and x is A. A. So we calculate velocity and tangent, yeah? So we solve these simultaneous equations. Should I delete this? Maybe, okay. So that's what I would like us to do. Okay, questions, comments at any time, please? Welcome, everybody, welcome. And then we go back to inertia once again. I would like us to be aware of the main moments of inertia, like disk, ring, cylinder, like the basic moments of inertia. And also another inertia force, it's called Coriolis force. It is occurring when something is moving along the rotating object. For example, a river, if it is flowing from north to the south or from south to the north, one of the shores will be steeper than the other shore. That's one of the manifestation of Coriolis force. Yeah. I would like you to be aware of the inertia force, okay? So that's what we have done before, but I would like us to go back a little bit and to study those topics again a little bit in more details, okay? I'm trying to give you more general things so that you watch videos, you read the books, you read the internet. So I don't really want to give you too much to calculate. I just would like to give you more to think so that maybe we can talk about things more than, just calculating things and measuring things, yeah? So the Kepler's laws. There are Kepler's laws. The first law of Kepler says that planets move along elliptical orbits in foci of which there is a star, or maybe there are stars, right? Okay, in foci of which there is a star, it's okay. So second law of Kepler says that the planet covers the same area during the same time, moving faster closer to the star and slower when further from the star, okay? And third law of Kepler says that period squared divided by average radius cubed is the constant for all the planets, for all the orbits. So it's in the curriculum of physics, laws of Kepler. So we need to be aware of them. And maybe we will be using the planetary model of atom. Let me write it down before I forgot. Planetary model of atom. planetary model of atom, and in this case, laws of Kepler may be relevant because at some point people thought that atom is just like, you know, planet and its satellites, or star and its satellites. Of course, now we know that it's so much more complex and it's very different. For example, the orbits of planets and stars and asteroids are usually plane orbits, whereas orbits of electron, they're three-dimensional orbits. Like S is a sphere, and then more complex orbits like D orbitals, we call them orbitals, not orbits. Orbitals, S, it's a sphere. D orbital is more complex. P is in between D and S, etc., etc. So, yeah, but yeah, planetary model of atom is kind of significant as well. Yeah, that's why we may need laws of Kepler a bit later. Okay, and now I would like us to study standing waves with characteristic equation of L is equal to n times lambda over 2. Well, lambda is the wavelength, n is the counter, and goes 1, 2, 3, 4, 5, 6, 7, etc. to the infinity. So waves in ocean can travel a great distance, just like sound waves, but some are confined to a specific region. Like if you shake rope with one end, fix it in space. Wave will travel down this rope and then back again, reflected at the boundary. Some waves are confined between two fixed boundaries, like string, where they experience reflection at both ends of the string, resulting in a multitude wave cycles traveling in both directions. In this vibration, if this vibration is of particular frequency, it will produce an interference pattern that is a stationary wave. These are called transverse standing waves. These kinds of waves can only have particular frequencies for strings of given length because they only have integer number of half wavelengths, since the waves must return to zero amplitude at both boundaries. If the number of half wavelengths was not an integer, the wave could not exist. This means that number of half waves must be quantized, meaning it can only exhibit certain discrete values, set of integers, and not from continuous spectrum. Standing waves contain nodes where there is a destructive interference and amplitude of 0, as well as antinodes where amplitude is at maximum. The string will be stationary at the nodes and other sections if vibrating rapidly enough, will appear to a human eye to create loops, and more nodes mean more energy, okay? Two-dimensional standing wave also exists, waves, I would say waves also exist. The nodes are lines and curves. In this case, standing waves are used in music, so that's why people enjoy certain kinds of music, and I will ask you a question about that. So I would like you to answer these questions to fill the blanks. Any standing wave must have an integer number of what? Half waves, yeah? Half wavelengths. In a standing wave, the place with zero amplitude are called nodes, yeah? A standing wave with greater frequency correspond with greater energy, yeah? So, and what song do you like? Why? How is it related to standing waves and to physics in general? I would like you to answer this question. Let me see. Yeah. Okay. So we also need to discuss this topic of electromagnetic interaction is responsible for almost everything in classical physics, like friction, elasticity, plasticity, fracture, thermodynamics. So we've been discussing this for a while already, but still it's important to mention that and to think about that. Yeah. Okay. So, and I'm asking you, what force is responsible for almost everything in classical physics? Friction, elasticity, plasticity, fracture, thermodynamics. Of course, it's electromagnetic force. Yeah. Okay. Now, if there are no questions about mechanics and the general things, I would like us to go to fluid, and you please ask the question, how will water level change if the floating icebergs will melt? Remember, we've been discussing this for a while. So how do you think the water level will change if all floating icebergs will melt? What do you think? It will not change at all. Many people get confused about that, but if all the floating icebergs will melt, the sea level will stay the same. Yeah, because of what we have learned in thermodynamics and in fluids. Yeah. So please be prepared to answer this question. And only those icebergs and ice, pieces of ice, which move from the land to the ocean, they will increase the sea level. That's true. Yeah. Okay. And here is the formula for the resistance force in fluid mechanics. Here, C is the constant, rho is the density of the fluid, A is the cross-section of the object which moves in the fluid, and V is the velocity of the object which moves in fluid. And I ask you to calculate for your student number the resistance force in the fluid. The fluid resistance force, okay? So all of them are equal to your student number mod 25, and that's what I ask you to calculate. And depending on your student number, it will be either one or two significant figures. Yeah. And continuing with fluid dynamics, I would like you to be aware of Euler's equations for fluid with zero viscosity. It's a simplified system of equations, but still very important and still solves many problems in fluid dynamics. Yeah. So simplified model, and more general model is Navier-Stokes equations. This is for viscous fluid, and remember we've been discussing Magnus effect and Bernoulli's principle. So Magnus effect can be described using Navier-Stokes equations, and not only Magnus effect, but many other effects are described using Navier-Stokes equations, which describe fluid which is viscous and more complex and more general. Yeah. So I would like you to be aware of Navier-Stokes equations. Okay, any questions about fluid and classical mechanics, please? Or anything else? So we want to move to thermodynamics. Yeah. If we want to increase thermal exchange, then we stretch, increasing our area. If we want to decrease thermal exchange, then we contract, decreasing our area. So the question is, why do cats often stretch in hot places? What do you think? I'm sure you have seen a cat stretching in Indonesia. Why do you think this is the case? Well, they try to increase the surface area to cool down. That's what they do. Yeah. To cool down in a hot environment. Yeah. Okay, heat transfer happens through conduction in solids, convection in fluids, and radiation in vacuum. Yeah. So please be aware of those heat transfers. I ask you about that in this question. And then we discuss the laws of thermodynamics, the zeroth law of thermodynamics, which states that if two thermodynamic systems are both in thermal equilibrium with a third system, then the two systems are in thermal equilibrium with each other. So this is important, zeroth law of thermodynamics. And the first law of thermodynamics is basically the conservation of energy. Yeah. Now, the second law of thermodynamics is probably the most important, not only in thermodynamics, but in physics in general. It talks about entropy, which is increasing. In other words, the level of chaos increases in the universe. Yeah, if the system is thermodynamically isolated, eventually the temperature becomes the same. Remember, we did it in the midterm exam. Yeah. So that's why we really need to make sure that our temperature is appropriate so that we can live comfortably, because the average temperature in the universe is approximately minus 277 degrees Celsius, at least in our part of the universe, which we know about more or less. Yeah. So we cannot live in this environment. So we need to take care of ourselves so that the temperature is good enough for us and for other organisms to survive and to flourish. Yeah. Okay. And then the third law of thermodynamics says that the entropy of a closed system at thermodynamic equilibrium approaches a constant value when its temperature approaches absolute zero. Yeah. So please be aware of the laws of thermodynamics and of entropy, which is the measure of uh, disorder in a physical system. And it can be wider than physics. It can go beyond physics, not only in physics, but also in the society, in biological system. You know, it's a very, very important concept. And enthalpy is also a very important concept. Enthalpy is the sum of thermodynamic systems' internal energy and the product of the pressure and volume. Yeah. So it's important quantity in thermodynamics as well. Yeah. And now, if you don't mind, we move to the work of gas. You know, the work of gas is the product pressure times the volume. Yeah. Um, during change of volume, and we will need it um, to analyze the heat engines. So this is the definition of heat energy. We need to be aware of that. Yeah. And internal energy, which is the energy contained within, and it measured as the quantity of energy necessary to bring the system from its standard internal state to its present internal state. Yeah. So internal energy is another important concept we must be aware of. Okay. And now we look at isothermal process, which means the temperature is the same. And you can watch this YouTube video about that. Isobaric process means the pressure is the same. Isochoric process means the volume is the same. And adiabatic process means that there is no heat exchange in the thermodynamical system in this case. Yeah. So, and now we go to heat engine. This is efficiency of heat engine. 1 divided by, 1 minus Q2 divided by Q1, where Q1 is absorbed energy and Q2 is dissipated energy. Unfortunately, Q2 is always non-zero. It's always more than zero. So therefore, the efficiency of heat engine is pretty low. And it's like maximum maybe 35% at the most, even the best heat engines. And of course, the oldest heat engine, such as steam engine, was extremely inefficient, only like few percent efficiency. Yeah. And I would like you to calculate the efficiency of the heat engine if I give you Q1 and Q2 in joules. Yeah. So it's only one significant figure. So please, you will have to calculate this and give me the number to one significant figure. Yeah. To one significant figure here. So please do some calculation. We need it, yeah? And now we can calculate the temperature. If we have Q1, Q2, and T2, we can calculate temperature T1 using this formula. And once again, I would like you to do the calculations to one significant figure. Yeah. This time, please do calculations because no student number is here. So please do the calculations and give me the answer to one significant figure. Yeah. So probably one of the most important Carnot cycle, it's basically the steam engine cycle. Yeah. We'll try to study this in depth a little bit later. Now, I just want to review what we are to study. Yeah. So Carnot cycle is basically the cycle of steam engine. So it's external combustion engine, very inefficient, only few percent efficiency. Now, Otto cycle, it's already internal combustion engine. Excuse me. So it's more efficient because combustion happens inside the engine. It's like gasoline engine, like motorbike, maybe something like that, yeah? And diesel is the most efficient, and it's used like in trucks, in other mechanisms that are pretty efficient, and we'll try to study this a little bit more a little bit later. Yeah, I would like you to be aware of these engines. So comparing the efficiency of Carnot, Otto, and diesel cycles, of course, diesel is the most efficient. You see that on the diagram, the area is the biggest. The area on the diagram, volume versus pressure, is the work. Remember, we discussed that a little bit earlier. And for diesel, this area is the biggest. For Otto cycle, it's a bit smaller. And for Carnot cycle, the smallest. So that's why Carnot is the least efficient, Otto is a little bit more efficient, and diesel is the most efficient, okay? Questions, comments, please. Okay. Excuse me. So we have answered this question, what color is the sun? So it's either green or blue, or some of you argued with me. It's okay. It's okay to argue with me. Just make sure that you express your own thoughts, not just copying or paraphrasing what you have seen. Yeah. So therefore the sun is green, or you can say blue. It's in between blue and green because that's where the maximum is if we use the radiation theory for the sun. But we have answered this question in the midterm exam, so I don't really want to spend too much on that. Yeah. And in optics, we will try to cover a converging lens and diverging lens, as well as concave mirror. Concave mirror it's a converging mirror. It can be used as a like a concentrator of rays, like as a weapon, maybe. Yeah, but maybe we'll discuss this a little bit later, okay? So just like we said before, light can be reflected, refracted, and also absorbed. There are three ways of light interacting with the environment, yeah? So we will try to study absorption of light, yeah? And going back to electric circuits, we will calculate the compound capacitance, just like we calculated compound resistance for the midterm exam. And this time, in parallel case, we add up capacitance because this is just one big capacitor, if in parallel. But in series, we do 1 over compound C is equal to 1 over C1 plus 1 over C2 plus 1 over C3. C1, C2, and C3 are capacitance of the capacitors, yeah? So as you can see, it's the other way around. It's different from resistance. For resistors, we added resistors in series, and it was 1 over R is equal to 1 over R1 plus 1 over R2 plus 1 over R3 for the case of parallel circuit for resistors. But for capacitors, it's the other way around. Yeah. As you can see, the equations are the same, just kind of they have different meaning. Yeah. I ask you to calculate, and this time I ask you to calculate and give me the number, yeah, to one significant figure for the capacitors. Calculate, please, compound capacitance, okay? So we need to be aware that the resistance of capacitor to direct current is infinite. It's infinite because capacitor, as you can see in the circuits, is drawn as a gap in the electric circuit. But it's not a gap to alternating current, but it is a gap to direct current. Now, the resistance of inductor to direct current is 0. Inductor resists to alternating current. Yeah. So that's quite important. We should also be aware of Lorentz force. It's a force which is acting on a particle which is moving in electromagnetic field. Yeah. And we will try to calculate Lorentz force. Yeah. And probably the most important in classical electrodynamics are Maxwell's equations. They are really great. They are really beautiful and powerful, super powerful. And we'll try to study them a little bit more, yeah? But I want you to be aware of Maxwell's equations, and please read about them in the textbooks, on the internet, on YouTube, watch the videos, and hopefully we'll study them a bit more, yeah? So there are electric charges, obviously, but there are no magnetic charges that we know about. And in Maxwell's equation, you will see that the divergence of magnetic field is equal to 0. In other words, the lines of magnetic field are closed, whereas the lines of electric field are opened. So they start in plus and they end in minus, yeah? Whereas we don't have separate magnetic charges. We always have south, north, and south at the same time in magnets. We don't have separate north and separate south in the magnet, yeah? So that's very important property, and it's very interesting. Maybe this is true only in our part of the universe, maybe in other parts of the universe, or maybe in parallel universes, and there are magnetic charges, maybe. It would help a lot if there were magnetic charges. That would make Maxwell's equations symmetrical and maybe more powerful. So I would like us to be aware of the transmission of the signal using amplitude modulation, frequency modulation, and phase modulation. Those of you who know about signal transmission may be aware of those things. We may try to study this a little bit more, a little bit later, yeah. And we can jam the signal by transmitting another signal which interferes with the useful signal, and that's used in the military quite a lot. So this is the application to the military, and we need to be aware of those things. And in physics of drones, we use all those amplitude modulation, frequency modulation, phase modulation, radio jamming, and also, of course, classical mechanics and thermodynamics and fluid dynamics, moments of inertia. Almost all physics, and of course, quantum physics is used in drones. Probably drones are now the most important thing that people are dealing with for many purposes, especially in the military. Yeah. Similar to missiles and bombs, unfortunately, we need to study those during the wars. Okay, questions about electromagnetism, thermodynamics, and classical mechanics. Okay, so now we'll try to deal a little bit with atomic physics. So we will try to estimate the distance between the atoms in the element T of periodic table. So if you cannot find your element here, just choose one of those elements that is in here. So we basically use the Avogadro number and the atomic weight, which says how many kilograms contain Avogadro number of particles. And then we use the density to calculate the distance, approximate distance, of course, between the particles. Here I have done it for several elements from the periodic table. Yeah, if you want, you can try for your T number. Periodic table gives you that opportunity. Okay, so maybe we can study this in depth, but basically it gives you the equation, how to calculate that. Yeah, using density, Avogadro number, atomic weight, and then taking the cube root and dividing by the cube root. And it will give you the approximate distance between particles of this element. Yeah. This is just for copper, one of the elements. Okay. And for particles, so the energy of photon energy is equal to some constant h times the frequency. Yeah. So energy of photon, let me write it down. Energy photon. We need to study bosons and fermions, maybe a little bit later. I think we will study maybe boson, fermion, fermion. We need to study those, but probably a little bit later. Now, we know that the energy of a photon is some constant h, very important Planck's constant, times the frequency. And we can rewrite it using the equation, the wave equation, as energy is equal to h times c divided by lambda, where c is the speed of light and lambda is the wavelength. Yeah. So speed of light is c and lambda is the wavelength. So you have the energy equation, hc divided by lambda. What is momentum? Can you tell me? What will be momentum? Remember, we've discussed that in mechanics. So if we have equation for energy through velocity of light or speed of light, what is the momentum? Well, we just take the derivative with respect to the speed, yeah? So momentum is going to be just h over lambda, yeah? And that's what I would like you to calculate. So if you have frequency then you can calculate the energy and momentum. Yeah. And it will be either 7 or 8 significant figures depending on your student number. Please do use your student number here. Please type your student number here. This time I need your student number, and just give the correct number of significant figures, and no need to calculate this time. If there is your student number, then I don't ask you to calculate. Just change to your correct student number and give the correct number of significant figures. That's it, yeah? Is it 7 or is it 8 for your case? Yeah. So similar problem. Once again, please use your student number here and calculate energy momentum of photon for lambda nanometers. So you have the wavelength. So similarly, you can calculate the energy, and you can calculate momentum. Yeah. So once again, give the correct number of significant figures, and no need to calculate if your student number is typed correctly, but give correct number of significant figures. Yeah. In my case, it will be 4 significant figures, but in your case, maybe different. Yeah. Okay, if we accelerate electron through the um, potential difference, we use the equation mv squared over 2 is equal to VQ, where V is the voltage and Q is the charge, because V times Q is work, and it's equal to kinetic energy, mv squared over 2, and we find velocity, and everything which has velocity and mass, which means has momentum, it has the wavelength. Even if I move, I have the wavelength. Anything which moves and has mass has the wavelength. So those are called waves of matter. Electron is not a photon, is a particle with mass, and yet electron has its wavelength. Yeah. We have the charge of electron, it's known. We have the mass of electron, it's known. Yeah. So once again, type your student number here, and then give me the number of significant figures. Is it 1 or is it 2? In my case, it's 2 because my T number is 56. It has 2 significant figures. But in your case, maybe T has 1 significant figure, then the answer will have 1 significant figure, yeah? So similarly, we calculate the wavelength of the desk. As you can see, macro object, like having the mass of, for example, several kilograms or several grams or whatever. So please type your student number here. And once again, depending on your student number, it will be either 1 or 2 significant figures, right? Let me check. I want to make sure. So V is oh yeah, PMV. Yeah, okay. Okay, correct. So indeed, either 1 significant figure or 2 significant figures. Yeah. So what is the matter wavelength of T grams book? T grams book. Well, if it doesn't move, then it's infinity, right? According to this equation. But if it moves, then we can calculate the wavelength. Okay. And then we will use the hydrogen atom energy levels and angular momentum equations according to Bohr's model. Yeah. And is it 7 or 8 significant figures for angular momentum? Please make sure you do it correctly, and please type your student number here for Bohr's model. Yeah. So we already studied the atomic structure and the models of atomic structure. So it is probably quite obvious that massless particles are probably better for quantum computation because it is easier to transmit them and to deal with them. But even massful particles can be used for quantum computing. Yeah. So then I would like you to perform correlation and regression analysis for the periodic table of T plus 2 elements and M7 plus 3 elementary particles. Yeah. You will see that the lifetime is usually smaller if mass of the particle is bigger. Just like people, if they're too massive, usually they don't live long. Usually, it's not always the case, but most of the time that's the case. Yeah. Similarly, it happens to particles, not only to humans. Yeah. Okay. And the next question is, what particles mediate electromagnetic interaction? Are they electrons or protons or positrons or photons? What do you think? So these are bosons. They must be bosons, yeah? Bosons. So bosons mediate the interaction. And for the case of electromagnetic interaction, the answer is photons, D. Photons are particles which mediate electromagnetic interaction. Some people may say electrons or protons or positrons. No, wrong. Photons are bosons and they mediate electromagnetic interaction. And what particles mediate strong interaction? Also boson must be the particle. So neutrons, gluons, photons, protons. Gluons and photons are bosons. So in this case, gluons mediate strong interaction. So B is the correct answer. Okay. Okay. Now please do find the energy of photon with the frequency of as hertz. S is your student number. Yeah. So the photon has zero mass. So mass here will be zero. But momentum, we know how to calculate momentum using the frequency. Momentum times c, right? Will be the energy in this case. C is the speed of light. Yeah. So what is the structure of electron? We don't know. We don't know. We still don't know what the structure of electron is. Maybe there is no, or maybe there is, but we still don't know. So for us, electron is a structureless particle. We don't know. The science of physics doesn't know the structure of electron, if there is. But we do know the structure of neutron. Neutron consists of three quarks, two down quarks and one up quarks, and proton consists of also three quarks, but two up quarks and one down quark. Yeah, by the way, neutrons life time is approximately 15 minutes, but protons lifetime is billions and billions of years. So proton is extremely stable, even though proton is quite massive. That's an exception from the rule. Proton is quite massive, but very, very stable. Yeah. So annihilation energy, it's mc squared. So if you have, let's say, 1 kilogram book, the energy mc squared containing, which this book contains, is enough to provide enough electric energy for Jakarta, maybe for several days or something like that. So it's enormous amount of energy. So please put your student number here and give the correct number of significant figures. Yeah. No need to calculate. So we do the decay. We do exponential decay. We have the ratio of decay. So once again, please type your student number here. And this is the formula for exponential decay. Yeah. Make sure you give the correct number of significant figures and nothing else. Just your student number and correct number of significant figures. No need to calculate. Yeah. Okay. So fundamental physical interactions. How many times is electromagnetic force weaker than strong nuclear force? Well, it's 137 times, very famous constant alpha, 1 divided by 137. So that's the correct answer. So please be aware of the drop model of nucleus in nuclear physics. Yeah. Also about alpha, beta, and gamma radiation. So alpha particle is nucleus of helium, beta particle is electron, and gamma particle is a high frequency photon. Yeah, we need to be aware of those kinds of radiation. Depleted uranium is very important these days because it's used in weapons a lot. And yeah, nuclear physics, nuclear chemistry, nuclear reaction, we need to be aware of the basic nuclear reactions. And also nuclear fission and nuclear fusion, especially now when nuclear weapons can be used. We must be careful about that. We must be prepared to that. And nuclear fusion theoretically would be impossible, and only quantum tunneling effect allows this to happen. Yeah, so when we take into account quantum tunneling, then nuclear fusion becomes possible. And it's often happening in the stars, and people can also do that if they explode the nuclear thermonuclear bomb, hydrogen bomb. Yeah. So please be aware of quantum tunneling, and we must be prepared to possible nuclear war. Unfortunately, we must be careful and we must be aware of that. Yeah. Also, please try to use quantum computer. I give you the link, so please try to play with this. Yeah, with the quantum computer. So any questions about particle physics, about quantum physics and thermodynamics, electromagnetism, and classical mechanics? So we kind of sort of reviewed those topics very quickly. And also I would like us to review general relativity, which is basically, how gravity influences the space and time. So gravity kind of sort of curves space and time. And this is the essence of the general theory of relativity of Einstein. So the Nobel Peace Prize in physics in 2023 was given for the behavior of electrons. So I would like you to be aware of the Nobel Prize in physics of this year, 2023. Okay. So questions, comments, anything? Okay. So I just would like you to be aware of these things, and I would like us to maybe watch some videos. So, oh yeah, before doing that, let's do the presents, yeah? Bayu Arif Setiawan, are you here? Muhammad Diyar Ramadan? Nabhan Muhammad Raihan?
Dear person, sir.
Thank you, sir. Thank you, sir. Nurul Nabila?
Sir.
Khairul Ilham? Thank you, sir. Muhammad Andhika Putra Pratama?
Yes, sir.
Ibnu Salam? Adam Apiyasya?
Present, sir.
Ranga, thank you. Ranga Raditya Putra Pratama?
Present, sir.
Muhammad Farid Ali Wahyuddin?
Present, sir.
Muhammad Fauzan Bintang Afdisa? Carnela Raisha Wulur?
Present, sir.
Thank you, Miss. Virgi Fabrian Hermavan, Molisa Claudia Sapitri,
Present, sir.
Christian Jonathan Pascual, Siti Raihana.
Present.
Thank you, Miss. Arief Aprilianto, Grandi Damar Negara, Ali Sira Judin, Brian Jonathan Putapea, Mohammed Haikal Bagus Putra, Mohammed Naufal, Zabrina Fitria Ramadani Napitupulu.
Present, sir.
Okay. Thank you, Miss. Thank you, everybody. Okay. So hopefully I will not forget to do that. So what I suggest, we have, I think it's better for us to try to watch some videos. For example, the video about physics of a rocket. Let me see if we can watch the rocket physics. I would like us to rocket science, rocket propulsion. Oh, that's too long. So rockets. Maybe this one. We will see if it is helpful. If not, then I will try to stop it. Okay. So let me stop sharing. Let me share this. Rockets, National Geographic.
Round begins with edge. Life. Finding cause. Mighty wager. The earth high. Among the stars. Launching a rocket into space is one of humankind's proudest events. From space non-function. The structure and includes the rocket engine and oxidizer. Depends on each mission and consists of anything a rocket. First, thrust is the force produced by the weight is lifts into the air. Flight, the weight of the rocket will constantly change as fuel. It's called staging to reduce that weight and increase the weight. Method involves breaking up a large fall away at different stages of the launch.
Yeah, most of the time people try to control rockets, but sometimes there is a program in a rocket which humans cannot change. It depends. It depends. For example, if it is a missile or drone, for example, sometimes they put the program, the computer code already, which you cannot influence, because if you can influence, then the enemy also can influence. But I think that most of the rockets which carry people are probably controlled from the Earth, because people need to be, better prepared. Maybe some things are controlled automatically by computer program, but some are controlled by people. Yeah, I hope it answers your question. Okay.
Correct altitude is for the Chinese in 1232 A. Error. By this during the following centuries, it is launch vehicle system. Saturn rocket successfully launched at the 36-story building in looked to the skies and dreamt of touching. Science and rocketry are opening up possibilities for space than ever before. Whether our science
Okay. So, if you have no questions and if you have no comments, then what I would like to do, I would like us to watch this video about standing waves. Yeah. Let me try this. Oh yeah, not this one, that one.
standing waves. Wave motion can travel fluctuations at both ends of the train, traveling in both directions. It will produce an interference.
if current exists. This means that the than any value. In completely stationary at the nodes and the it's loose and more nodes. On a one-dimensional string. The sand gets pushed over to the nodes by the vibrations. Standing weight. A three-dimensional form. Of the consonant intervals in music. Then doubling this frequency to 200. Since of the first encounter in the modern physics course. Quantization of energy of an electron.
Okay. So let's see what else we can watch. Thanks. The Euler equation, but maybe not the Stokes equation. Excuse me. It's part one. Okay, I think part one should be enough.
Hello. Thanks into two ends. These equations In this video, we're going to talk about moving up a hill. Pressure gradient is a drive. Depends on velocity. Depends on extent. Concentration per unit volume.
Okay. Okay. So I think distances between atoms. Yeah. Let's see, this guy, right?
The distance between the sensors. Each atom. Calculate the finite volume. you as a dancer. And in 1 meter cube rock. So each one of these edges the value rivers on our this owner between any two. That means the length or the side. We can use any between the two.
Okay. So, see what else we can watch. We can watch second law of thermodynamics again, Professor Dave. Should on this one.
the easy engineering once again. And today's topic, the second law. This topic has made most and deliver a net amount of the entropy statement. It is P is destroyed. So, to make it easy, we made two easier statements that would help us more in understanding this law. So, well, let's call this as I. Temperature of coffee. Passing a balloon. If you open a small space, the balloon goes out. Lower transfer.
Okay, so that's second law of thermodynamics. Let me see what else we can watch. Entropy. Okay, I think we need to watch Carnot's cycle. Yeah. Let's watch Carnot's cycle. Yeah, that's the diagram I wanted to draw.
P1. From this The stage of I
Okay, so then Otto cycle. With 10, with 11. Maybe this is better.
You can see it clearly. I was okay.
Okay. And then also we need diesel cycle.
So cycle. diesel cycle. Creating a partial vacuum. And the piston moves up. Stroke is a ball. Before we end the video, let's talk about it has no spark plug. It has
Okay, questions, comments, anything? Okay, so let's see. Converging lens. I want us to look at those which we actually solve. Compound capacitance. Combined capacity. Yeah. Question? Well, why can't diesel fuel be used in non-diesel engines? Because non-diesel engines don't use the high pressure. They use the spark, whereas in the diesel engine they compress the fuel to a point where it ignites. But that's an interesting question. I need to think about that. Used in non-diesel engines. What piston is used for? Well, piston transforms the chemical energy of the fuel to the rotation energy, to the mechanical energy of the car moving or motorbike moving. In the case of auto cycle, it's motorbike. In the case of diesel cycle, it's a truck, for example. Yeah. Thank you. Interesting question. Interesting questions. Wow. Okay. So let's see. I want us to do the capacitance. So adding capacitors. Adding capacitors. Let me see if we can find this. Yeah, this one, right? But that's a long one. But anyway, maybe it watch it.
this instrument's highly integrated gallium nitride. That's talking about sensitivity. In this video, we're going to talk about capacitors and
Well, just like I said before, the significant difference is that the area of the diagram is bigger for diesel than for Otto cycle. So diesel is more efficient, and in diesel there is a compression which ignites the fuel, whereas in Otto cycle there is a spark which ignites the fuel. Interesting questions. Wow. That used for vehicles. Yeah. Usually motorbike has like auto cycle type of engine, whereas some cars they have diesel engines, like trucks, for example. Yeah, more efficient. Okay.
Let's use a 10-volt battery. Let's hope a value of 100. It's like fair. Cross every element that's parallel to another. Charge. And the same is true. So it's going to be C1, which is the 100 micrograms. Coulombs. That's the unit of electric charge. What is the charge toward Earth? It's minus 6 times 5. So 300 times 10 dollars. Electric potential energy stored. capacitors to have this much capacitance, but just when I think how much. A simple way to find the equivalent capacitance. Sometimes you may need to find the voltage of just one capacitor. One cues for me. So that's the total charge, which is take the charge and divide it by across C1. Now to find the voltage across two, they both equal to Q. So it's going to be 48 current. Five. adding onto the position pattern. That's talking about and so this is equal to 380.
Okay, questions, comments? Interesting questions about Otto cycle and diesel cycle, but not about Carnot cycle or anything else. So if you don't have questions, maybe we can finish for today. What do you think? So what we have discussed today will be in task 2 and in the final exam. So we will try to study those things and maybe we'll watch videos, we'll see how it goes. Yeah, maybe you can answer questions, maybe you can ask questions. Yeah. It was interesting when you asked about Otto cycle and diesel cycle. Wow. Okay, so thank you so much, Terima kasih banyak. Thank you for your patience. Thank you for your effort. Thank you for your time. Okay.
Thank you, sir.
Thank you.
Thank you, sir. Good night.
Thank you.